Okay, so here we'll be looking at number of ways of expressing a number as a product of two of its factors. So this is a continuation to our previous lecture where we saw the product of factors, the number of product of factors. So again, we'll be dividing the numbers number n when we'll divide it into two cases, when n is not a perfect square and when n is a perfect square. So again, we'll be using an example to solve and explain the particular concept. So let's take here n as any number. We can take n as equal to 12, which is not a perfect square. So the factors of n here would be, so this n could be written as 2 into 2 into 3. So n factors would be 1, 2, 3, 4, 6 and 12. So there are 6 factors here. So let nf be the number of factors. So we have 6 factors here. Now let's make pairs of these factors such that the product is 12. So whenever we are taking one as a factor, the other factor has to be 12, so to make the product of 12. For 2, the other pair number has to be 6 to make the product 12. Similarly, for 3, we have got 4. So we have got 3 pairs here to make the product of those pairs equal to the number itself, which is 12. So the total number of ways to select two factors such that their product is the number itself n is given by nf upon 2. Now this is the case when n is not a perfect square. So it will always be there will be always nf upon 2, that is total 6 upon 2 equal to 3 ways to choose any two factors such that their product is equal to the number itself. Now let's do it for the case where n is a perfect square. So let's take n as equal to, let's take it to be 36. So here the factors would be 1, 2, 3, 4, 6, 9, 12, 18 and 36. So if we try to make pairs here, we have 1 and 36, we have 2 and 18, then we have 3 and 12, we have 4 and 9, and 6 could be multiplied by 6 itself to get 36. So it depends here, we can divide it into two conditions in fact. If repetition of factors is allowed. So clearly if repetition is allowed, we have 5 ways to get the product of 36, and clearly the second case will be repetition is not allowed, and in this case the number of pairs we will have is 4. So if the repetition is allowed, the number of ways we can get two factors such that the product is equal to the number itself would be nothing but nf plus 1 upon 2, where nf is the number of factors. And similarly, when repetition is not allowed, the number of ways to get two factors such that the product is the number itself would be nf minus 1 whole upon 2. So these are the required formulas by which we compute the number of ways to get two factors of a number such that their product is equal to the number itself.